Hello everyone, am I audible? We'll just wait for a few minutes for others to join and then. In the meantime, I can take some questions if you have from previous topics we've seen or anything previously or any such thing. Like I was saying, if you guys have any questions, I can take them and we'll start in a few minutes. Okay, I guess I'll start. Right. Yeah. Just a clarification from last week. Uh, we had this error while compiling this standard vector of standard vectors. I was trying to show you guys how to declare and like you have 2D arrays, right? So you can define it through the double brackets like we saw. So this is stack allocator, right? But let's say we want to do it more C++ way and much cleaner way also and have it heap allocated. So one method I was trying to show is with standard vectors of standard vector. So apparently with at least Clang, it throws error if you, so it misinterprets these double angular brackets as bitwise operation, right? So hence it's an error. So you just have to separate them and then that should work. It should take care of these error compilation issues that we were facing. Now thing is with these codes it should be available to you guys along with the recordings of this class. So do if you guys haven't received them, do mention in the forum or something, or maybe write to PMRF support. This codes that whatever examples I do and whatever this lecture recording is, it should be made available to you. Okay. Um, like I said, feel free to ask questions in between if you have any specific doubts you want me to discuss or any such thing. Okay. Uh, I'll continue from last week. So last time I was seeing we were seeing the hash defined function and macros, right? Preprocessor and constant values. So I'll quickly discuss the inline function, which is used in C++, and also why you should actually avoid using hash defines also. So yeah. Hash defines, like we discussed last time, they work as so hash defines replace the defined values even before the comparison begins. So that can actually lead to a lot of errors and even debugging becomes harder. So inline also is like a safe way to do this. So okay, let's write the same function in inline and hash defines. So started hash include and string. No, okay. Um, we'll start with first writing the macro first. Yes. So versus define hash to define square, let's say the square two values, or maybe just call it add, and it takes two values XOR and returns. It's more. It's not even return. It's more like replace. So yeah. Important thing to note is there is no semicolon. It's not exactly a code or statement that you are ending. It's just a preprocessor which says they define my add function as this with taking parameters x and y, and then just replace that wherever you see add with two arguments, just replace with x plus y. Okay. Let me define integer, let's say a equals to 5, integer b equals to 8, and then c equals to uh, a. Let's print this. Oh, yes. My bad. Sorry. It should be standard C out. PC out is something one usually does in parallel codes. So yeah, my bad. Great. So right. So we saw how to use hash define to define. You can actually define functions. You can define values also. So like hash define some constant also. You can if you want to define some constant, let's say pi. I mean it's already available, but let's say you want to define pi uh, constant as 3.14 or something. Then you can just use this macro itself and replace wherever you want. So you can just have something like value of pi as this, right? And yeah, so it shows the answer for C as you can see, and then the value of pi also as is basically how you define it, right? And but let's say we want to do the same thing, but not as using macros, but much more C++ and much more cleaner way also with less potential for error. We'll do it with a function, which is an inline function. Now, why? What's the difference here? Inline is also a function with a qualifier like this inline, and then let's say you want to define a whatever the data type. So it's like it returns integer. So integer add define, which will take integer x and integer y. So now we have to define what x and y are. Here they need not be integers. Actually, I could do them with doubles also. You can define double A, double B, and then pass uh, them to add macro. This will work because plus operator is defined for doubles. So you can here you don't need to change it. So that's one advantage there. But it's still better to do it this way because they are actually explicitly defining what the variables are, and it's much cleaner also. You can always overload the same function, so that's okay. So you return x plus one. Yeah, that's it. Now, thing is, uh, yeah. So like I said, what is this inline, right? So inline itself is also a function, but the difference is that um, while a function will get called. So for example, here we'll have a function called, let's say, integer c equals to a comma b. So if I have a function called like this, the add function, like as usual, it gets called here. The values are passed, but inline does a similar operation as macro, where the body of the function it just replaces. So the overhead associated with passing parameters and calling the function, those things are avoided. So if you have codes where you're going to call certain function many times, it's better to do them inline. So yeah, that is the main advantage of using inline. It essentially works like hash define, but you don't have to worry about the other baggage in a way that comes with using hash defines. Here you can simply have adds, and because it's a function, you have much cleaner uh, definition. Like, okay, I'm passing integers, and this is a function call I'm doing, and so on. But with if I have a capital like some defines like this, it will just start replacing the whole code, and you don't know what's happening where, and so on. Okay, let's print this and see. Yeah. So this also works. So we have add, we saw add done in two ways. One is the macro way, and second is the inline way, the C++ way. Different. Now, Today, we'll also look at a very important concept in C++. And the main reason C++ is widely used, it's the object-oriented programming concept. Now, object-oriented programming is like heart and the core of C++, where you define certain kind of rules in a think of them a class. Like what I'm saying is basically a class. Define a set of rules and then reuse that for different use cases. Essentially, that's what you do. Now, let's look at some basic things, how classes and what are its different, um, what is this member, what is this attribute, what are these methods, and so on, things like that. Okay. Right. So let's define a class. Class. So as usual, we need to print something, so include this guy. Then we always have main. That's okay. Now, what we'll do is for this, we'll also define something called a class, a very basic class. So we all know about complex numbers, right? So let's define a class called complex. And there, sorry, yeah, there I will inside this class, I'll have some member variables in a way you can think of, which are called attributes. So this class will contain, so because it's a complex number and we all know complex number have two parts. One is the real part and the imaginary part. So this class complex I will use to define complex numbers because by um, mm, there are, so usually there is no inbuilt way of defining complex numbers. So a lot of people just use this class way of defining, right? So same thing you can do. So previously in C, people used to use structs to do the same thing. Structs are also very similar to classes only, but classes are much more features and other stuff with in C++. So what we'll do is define something called a public. So what happens is in a class, you have public and private data members and functions also. So public will have, it's as if, okay, so maybe I'll define public later. Once we see how this class works, maybe then I can come to. So let's define the class members, different attributes. So the numbers will be, I'm thinking there'll be doubles. So we can have like R and imaginary, real and imaginary. Now these are data members. So this class has two data members, which is one is the real, we just write and imaginary. Yeah. So how to use this class? So the way to use this class will be to define, to instantiate it first. So I'll define. Okay. You can think of class as a custom data type also, like how we do in structs, right? So we'll have some. So the name of the class as the data type is as a user defined data type in a way. So complex. And then the C is the object. What I mean by that is a class is just a blueprint, right? It's just a set of rules, but to use them for my specific case, I'll have an object. Okay. So calling it this way and then maybe write it as some numbers 1.0, 2.0. Right. So here what I did was I defined my class. So this is called a class instantiation. So automatically the object gets created. So which is C. Now the variable C is the object, which says ki the it will have all the same rules, all the same functions, all the same variables as are defined in the class. Now I can define multiple objects also. So I can define a C complex. So here, let's say it's a C1 is one complex number, C2 is another complex number, C3 is another complex number. And I can have something like 4, 7, then this, let's say, be 8, and this be 10. So all these points, like I comma j, right? So 1 plus 2i, 4 plus 7i, 8 plus 10i, I can represent by using the same user-defined data structure. Right. Now, complex, just I hope that is clear. So complex is like a basically a user-defined data type, where according to my use case, so here it will be defining complex numbers. So according to my use case, I can define variables. So like, let's say sorry, not the variables. I can pass the arguments, which will be like the real and the imaginary part of the complex number to the class, and then have different objects of the same class for defined on the same class. Okay, I hope this is clear. Now, the variables I defined are C1, C2, C3. Okay. Now, the nice thing is, because all the objects of the complex of the class have access to real, imaginary, and so on, we can actually print them and see. So, for example, let's see how. I'll print for C1. Um, Real. So I'll access the member variable by real. Okay. And then the imaginary C1 dot in, and then enter. It's printing. Oh yeah, my bad. So class you have to end by a semicolon. And good thing we have companies. Yeah. So yeah, let's do it. Let's do this. So for this user-defined class, the first object we created was C1, and then I printed the values. So the way you access the attributes or the variables inside a class are through dot. So you just do the class dot the member name, right? The attribute real, and that's it. That should take care of accessing that variable. Now, since 1 and 2.0, this 1.0 and 2.0 were passed, so internally the class for C1, the object will store its real part as 1.0 and its imaginary part as 2.0, and similarly for the rest of it. So let's print and see to confirm. Great. Now we can see that this C1, which is which we defined as 1.0 and 2.0, that printed 1 and 2. C2 we defined as 4 and 7. So again, the real part got 4, 7. And for C3, it was 8 and 10. Yeah. So I hope this is clear. This is a very basic way of writing class and accessing its member functions. Okay. Now, yeah, what you can do is you can actually use a class as so because it's a user-defined data type, right? So you can use that inside other classes also. Okay. Now, what you can do is you can since it's a complex number, I'll define it to be for let's say I'll define yeah maybe line segment, right? So I'll define line. So the first point will be, so yeah, so complex. So let's say point one, P1. Okay. And then P2. So this line will have 2 points. First point is a complex number. Second point is also a complex number. So that defines that line segment in a way. Okay. So let's define this also. Maybe maybe move this to a new file. Use the same definition of this class. Yeah. Now I'll use the complex data type and then define this line. Okay. So as we saw here, we define user defined class object as such. So we can do the same thing for this line also. For define line, let's say L1, okay, equals to, you have to end it with two pair of points, like, so a pair, actually a pair of 2 points. So do it something like this. Maybe 0.0 is the first real part, and then 1.0. So this is the first complex number, the first point itself for the line, and then second will be something like, let's say 5.0 and 10.0, and then the line. So similarly, I can then uh, define something else. So it's like, oh, this one connects. So this line, in a way, if I want to visualize this one, this line connects point 0.0, 1.0 to 5.0 and 7.0. Then I can represent rectangles, complex shapes, and so on from this. So I can probably construct more and more complicated shapes defined by using this line, right? So I can do something like maybe maybe let's do that. So 0.0 and 1.0, that's 1 point. So maybe let's make 0.0 to 0.0, and then from 0.0 to 1.0. Okay, that's the y value. So it's the line connecting origin to the y-axis 1.0. Okay. Now I can make 0.0 to 0.0, and then here will be x, right? Okay. So it's on the x-axis, origin to uh, value 1.0 on the x-axis. Similarly, the line 3 will be, can anybody say? In the chat? Okay. It will go from let's take it 1.0 only, from 1.0 to 1.1. Okay. And similarly, from 0 comma 1 to 1.1. Yeah. So in a way, I've defined a square here, right? And let's compile and see. let's see the issue. Then maybe we can just define it this way then. Um, could be a compiler thing, so probably some compilers don't allow certain things. So yeah, let's define it this way and then pass those values themselves. So pass me point one and point two. Okay, probably something else is missing. Anyway, I think we get the general gist of the thing, the idea. Okay, so let's define some functions also. We can take the example of this same class itself and define some functions. So what we saw here are these real and imaginary. They are called member variable. These are called attributes. These members are called attributes, the variables. Now we'll have something called methods, which are functions defined inside the class. Okay. So what we can do is define some functions and then access them from the as a method to the class. Okay. So one thing one can do is distance from origin. So because this is a complex number, you can definitely define distance from the origin. So that would be something like double. So let's call it distance. It doesn't need any input because already it has access to real and imaginary points. So we can just define the function from there. Yeah. So let's define that. Sorry. So distance will be standard. So what I'll do is use the standard square root from C++. It's in the default standard library. So square root of real part. Okay. So square of the real part added to imaginary 10 times. Now, this here I've defined a function distance, which should return this. Yeah. We should return the square root of the real part plus the square of the real part plus the imaginary part. Okay. Now this should give me a distance for any of this complex number. Okay. Now let's see that. So I can call just like this. Now notice the difference. You do access the member function also through the dot function. Okay. But you still have to end with the brackets. Oh, there's a question in the chat. What's token casting open? Um, I don't think I understand the question. I think you mean token passing operator, maybe. So yeah, here the idea is also similar. You can have variables passed. Okay. So here also you still can pass variables. So there are there are few ways you can do this. One is like we discussed last week, by a copy or a move, or as in like by reference or by a copy. Okay. Now here that the function doesn't need any arguments, so hence we're not passing. But yeah, let's Try and printing this and see. So distance from origin for this value or C1. Yeah, distance from origin for C1, this, and then N. Sorry, no, this one. Yeah. So for the complex number C1, the distance is this whatever 2.236 is the same. Similarly, we can calculate the distance from origin for others. So it will be 2, 2, 3, that gives me the values from distance from origin for the other complex numbers also. Yeah. What's the question in the chat? On the final maybe or else discuss previous questions. I'm not sure if I'm allowed to discuss questions from previous year, but one thing I can tell you will be the format will be similar to what you're getting in assignments. So as far as I know, but you can get clarified from the other TS because I'm not the one who is setting the questions. So you can probably post it in the Google group, the discussions group of NPTEL for this course. Maybe ask there also to clarify this. But as far as I know, it will be similar to the one you face in the assignments. Yeah. I hope that answers the question. Yeah. Okay. Maybe let's move on. Now, yeah, there is something called yeah. So I think last week or last week we saw the lifetime or the scope of a variable, right, or a function or something. The scope for user-defined object like this is also within whichever parenthesis or the brackets you see. So here it gets initialized or the default constructor in a way that gets called. And after this, its default destructor will also get called. We haven't defined any constructor or destructor for this class, but there is a default constructor defined for classes in C++. So it gets automatically called, and whatever data or members or something, it gets cleaned up. So in the memory, what happens is this class is defined. That's okay. But when you initialize C1, then with this values, the program will create this C1, store the value with all the member functions, and it's defined function and everything. So whatever memory it requires, it will create all of that. It's a very small function, so this one probably won't create as much memory. But when you have very complicated functions, it creates all the data and stores in the memory. But and the lifetime or the storage exists as long as the object is in the scope. Like for as we see in the scope of this main function. As soon as it goes out of scope, like out of this brackets, C1 doesn't exist. So its a destructor gets called, or you can think of it like all the memory associated with C1 gets wiped out. So that's the basic idea. Yeah. There's yeah. So assignments question type also perceptual. Yeah. Yes. It'll be something similar to that. Yeah. So do prepare on the, like I said, concepts rather, and definitely practice these questions. There are some questions for these classes also in the lectures. So do practice them. And the more you practice, you will get better at all these concepts. So write the program. So unless you actually sit down and write, it gets difficult to understand what is actually happening. So write the programs, uh, go through the code, like, okay, this is what I'm trying to do, and then compile so that if you have getting errors, and then maybe you'll able to debug that, because usually it will be some syntax error, and then run the program and then see, is it the actual output you're getting? Because sometimes your outputs that you expect are not what you get, because there is some bug in the code or something. So to understand the concept, I highly recommend write these programs, and then you'll actually understand, like, okay, what is happening? What does this line mean? And so on, right? Okay. I hope this part of the class is clear. So here we defined a user-defined, it is a user-defined class, but we also have a function where we try to, which is like, in a way, you can think of it, it's specialized to this class, in the sense, this is distance means makes sense for this class, because I'm thinking of complex numbers here in this class. So I can always define some distance from origin, and then uh, calculate the distance, right? Okay. Okay, nice, nice. Then do you have any questions? Maybe I can take some questions if you have. I guess this so far this should be clear. Okay, so the nice thing is you can always change the variables by accessing. So let's say I have a complex number C1 and so on here. I printed them. Great. I can actually access the variables. So let's say C dot real and set it to be, let's say, 4 point. Okay. And similarly, okay. Oh, yeah, okay. Thank you. Yeah. And then imaginary also to be, let's say, 4.0. And then let's print C1. Okay. So the distance from origin will be different, of course. And let's do this. Okay. Yeah. So the original print shows the for the complex number C1, the values of 1 and 2. And then you can just change the values, but you'll still remember. Because remember, like I said, the C1 variable still exists, is still in the scope. You can access the variables, change them, okay, and then move on. Okay. You can just change them and then uh, play around, or whatever operation you want to do with them. So as you can see, we just change the values, and the distance also reflects the same, because it's at a different, it's just a different point. Okay. We're able to do all this because I defined the attributes to be public, and also the function to be public. But let's say I do not do that. I make them private. Okay. Let's see what happens. Yeah. Should throw error. So why all these errors, right? So what private actually, so there are two portions to a class. One is a public portion, and another is a private portion. A public portion is accessible from that object in the so you can access from wherever in the scope of the object. Yeah. So there's a comment in the chat. Yes, you can. So the objects can themselves access the private members, but in the scope of this object. So let's say inside main here, where the scope of C1, C2, C3 are, I cannot access the value real or even the function distance, because these are, I've defined them as private. Okay. But what happens when so I definitely need to define it. So I'll have this public variable. Let's define something else as private. Um, okay, no, let's define this only. But have another function. So let's say maybe distance variable. Okay. Here what I'll do is instead of return, I will store the value. Okay. And we can't call this function. So okay. I'll just maybe make double. May not be the best example to show this, but you can do something like this also. So what I want to I'm trying to show here is the variables, they could be private or public. Members have always access to it internally. So inside a function, let's say here, distance, even if it's a private function or a public function, it has access to, it has access to variables distance. Okay, that's what I'm trying to show here. We can probably do not distance, but like just a or something, and then just return the value, whatever is the value stored for distance as a function, or just call distance directly. That is also okay. Yeah. Now thing is, for this to happen, yeah, this function also needs to be called. So I guess that idea is clear. Yeah. Now hope that that is clear with privates and public. Now let's see what's the next topic we should cover. Yeah, another reason to have private variables is we sometimes don't want to have, let's say we are accessing an object. It's if its members are public and its some functions are public, that is okay. We'll have we'll access them, but sometimes you do not want other variables to have access to those values, right? So private helps in those cases. Private it keeps your code clean also. So so the functions or variables you do not want to know by the other variables. It keeps a good how do you put it separate basically. Yeah. Now that was with complex. Hmm, yeah, okay. So I mentioned something called a constructor and a destructor, but and we did not explicitly define them. So let's look at how to do that. Right. I'll define the same class complex. Okay. But this time I will have uh, like not use the default constructor like we did here. So I just defined variables, and when I defined the class, it automatically knew which variables to set and get, right? So that was okay. So this one. Okay. Yeah. So let's use those same values, but sorry, use the same ideas, but now we'll actually define the constructor for the class. So it's written something like this, and constructor by default it has to be public. So you can't have it in the private. So I'll define something like okay, we'll use the private variable private to define which variables will be private. So something like we'll write in this way. That's fine. Double real and imaginary. Okay, in the thing. Then we have public part where I'm defining. And remember, to define the constructor, the name of the class also has to be same. So as the constructor. So if I define it this way, then the class actually knows that this is the constructor I'm going to define, not the default constructor. Okay. If you do not define a constructor, then it will call the default constructor. So what I'll do is maybe define this as uh, private variables where what this does is it takes values, right? And then so maybe let's do the full thing and then see what's the actual difference. Yeah, so it ends with a, like you have to have a colon and then set the variables. So here I'm explicitly defining what the variable will be. So the real, which is the member of the class, will take the input value from the when the object is instantiated to this guy. And then same for this. So we use imaginary to define this. Okay. And then so this is the portion after the colon where you initialize the member variables of the class, whichever you want to do, whichever you want to initialize. Then you give a body. So it need not have anything, but you can give like uh, standard cout that initialized or complex initialized the class. Now we still have to end this class, yes. And what else? Yeah, here it will be a bit more cleaner. So let's say we define the distance function also here. So we'll have double distance. Okay, we need not take any value because we have the access, right? So takes the value, then returns. But remember, we can't use this real because this is the input to the complex, right? We have defined the real with underscore. It's just to keep things different. Okay. So the private member is actually underscore real. You have to use that type. Okay. Then so star real plus underscore imaginary times this whole square. Okay. Now should end it. Yeah, return statement. This should be return statement here. Yeah, now it is fine. So I format the document. Okay, great. So again, in C++, there is no need for it to be like next line or anything. As long as it's inside bracket, all these are equivalent statements. Something like write something like this or write something like this. They're all this. I hope that is clear also. That there should not be confusion regarding this. Then I'll have main function and I'll return 0 because I've been writing main. Let's define complex numbers, right? So let's say C1, but this time instead of writing it this way, we can write in a bit different way. So I'll define the same complex number 10 and 2.0 here, but this way. So this is something uh, actually, if you look carefully, I've already used. I've actually done previously also. When I do this, so in C++, you can also define variables with something like equal to, right? So it gets assigned. With brackets also, you can define the values. Think of it like another way of doing the same thing, but this has more implications because this actually calls the like here you see well in this like here you see it calls the user defined constructor of this class. Similarly, by by inbuilt how the C++ is constructed, variables like this, so which are let's say doubles, for them doubles, integers, and those kind of variables, there is already a constructor. Okay, so you can actually define something like so if I hover also it shows me with standard library namespace for complex, for doubles, and for reals. So you can actually do like just use the bracket, right? And then pass the value you want to for it to take. Okay. Now that's okay. I have, and let's see here. Then I'll just print, I'll just use the same lines. Okay, so let's print the imaginary and the real part. But the thing is, I cannot do this because I do not have the access to the variables. But what I instead I'll do is print the distance. That's better. Okay, I hope the difference is clear. I cannot access these variables. Maybe let's try accessing it. That should be clear. That should make things a bit clear. Here the variable will be real, and this variable will be imaginary. So then, yeah, as we expected, it threw error because even the compiler says note that the variable is declared private here. So previously we defined them as public, hence we were able to access. Sorry, hence we were able to access them. But if we define them as private, we cannot access them. Okay. I hope this thing is clear. But since we defined them and the variable is set accordingly by the constructor that we defined, we can access them here as such and then call the distance function though, because this is public. Okay, let's do that. Yeah. So here we can see that we access the same distance function, but in a different way. So it's like writing the same class, but in a different flavor. Yeah. So now let's say I don't, I have a variable, I have an object, but usually what happens is you just have functions which you want to call from like outside from here, and variables something you want to keep private. So this is one way of doing this. Yeah. So good. I hope this is clear, and feel free to stop me if something is not clear. Yeah. So we defined constructor. We can also define something called a sorry, a destructor where you do something like this. So use the quickly tilde, and then the same class name complex, okay, the bracket, and then the definition for whatever uh, it has to do. So I'll leave it empty. Let's see. Yeah. So here I defined a destructor for this class, but there is I'm not calling anything here. This is also a valid code, but it's essentially like defining destructor, but you're not cleaning stuff. But yeah, that's essentially what's happening. In C++, you have default destructors to clean all this. So even if you don't um, have a destructor, let's say defined, it will automatically clean this because this when this go out of scope, it should call its default destructor, right? Okay. But it's a good practice to define these values and define the body also. Yeah. Let's see. I hope this is clear. Yeah. I think I covered some of the topics that I covered for this week. Lifetimes, yes. Constructor, destructor. Yeah. Object lifetimes, yes. That's also done. Lifetimes, yes. And class. Yeah. I really encourage you guys to practice the problems because in classes are quite fundamental for C++. So understanding this whole object-oriented programming, where you use classes, define objects, then call its member variables, call its member functions, methods. That is like key to writing C++ code, and it is heavily used. So there are some practice questions you can definitely go ahead and practice. I encourage you to practice inside even the lectures. You can find them in the lectures also, and you can probably get some other online resources to do more questions. Even the books that sir recommended, you have questions in them, and you should practice like for sure. Um, I understand classes can be a bit confusing when you look at them at the first time, but I hope today you get a brief idea, like from at least from an overview, what classes are and some of the basic things you need to understand on that. Okay. So yeah. So if there are any specific questions I can take, or you guys can feel free to leave also. Yeah. Otherwise, yeah. Yeah. Question in chat. Yeah, actually, so like I was discussing, so this code also should be available to you guys. Um, I hope NPTEL should give you access to a Google Drive link where all the week's codes which I have discussed written here should be accessible to you guys. If not, please write to NPTEL because these codes I just upload every after every class. I upload the lectures. I upload the codes also, and you can actually take a look at them later. Yeah, so you can go through the videos also. They'll be in YouTube, and the codes also the codes themselves should also be for every week available. Yes, I hope that answers the question. Yeah. Yeah, go ahead. Uh, Live sessions every week. Yeah. So I'll every week Tuesday you'll have um, every Tuesday 6 to 8 we'll have this class. Feel free to ask questions. Yeah. Vishal, you have a question? Yeah, go ahead. Okay, so question is, I make a class and give access specifier. Okay. Then, sir, what program considered? Um, Maybe I don't understand the question, but are you asking like if you don't give the access specifier, how does the program know what to consider? Is that correct?
सर मेरा कहने का मतलब मैं क्लास बनाता हूँ, ठीक है?
ठीक है, ठीक है।
उसमें उसमें मैं एक्सेस स्पेसिफायर नहीं दे रहा हूँ, तो वो प्रोग्राम एक्सेस स्पेसिफायर में पब्लिक लेगा या प्राइवेट लेगा?
हाँ, by default it will be public.
बाय डिफॉल्ट पब्लिक लेगा।
Yeah.
सर रीजन?
Oh, that is the how it is made. Matlab, it is by rules.
यस सर।
हाँ
ओके सर,
बाय
थैंक यू।
हाँ बाय डिफॉल्ट वो
बाय
पब्लिक,
डिफॉल्ट
या बाय
पब्लिक
डिफॉल्ट
लिखेगा, यस सर।
हाँ पब्लिक ही होता है।
तो सर
हाँ
प्रोटेक्टेड का हम यूज कब करेंगे?
हाँ प्रोटेक्टेड थोड़ा अलग है। सो प्राइवेट इज लाइक हाउ टू पुट इट, वो उसका एक्सेस सिर्फ इसी को रहता है, ठीक है। मतलब
यस सर।
तुम्हारे ऑब्जेक्ट को रहता है। So
यस सर।
object can modify, object can even only access that those variables, वो जो वेरिएबल होता है they can only be
यस सर।
accessed by the object, ठीक है, बाहर कोई एक्सेस नहीं कर सकता उसको। प्रोटेक्टेड में
यस
यू
सर,
प्रोटेक्ट
दिखता
दोज
है।
वैल्यूज। हाँ
उसको एक्सेस सिर्फ ऑब्जेक्ट में ही कर सकते हैं ना सर?
ऑब्जेक्ट ऑब्जेक्ट सब कुछ एक्सेस कर सकता है एक्चुअली, इफ यू थिंक अबाउट इट। प्राइवेट में एक्सेस कर सकता है, इट कैन एक्सेस प्रोटेक्ट, इट कैन एक्सेस पब्लिक, सब कुछ।
तो सर जैसे हम
हम्म।
क्लास को प्राइवेट में, क्लास में कोई एक्सेस स्पेसिफायर ना देंगे तो क्लास का हम उस क्लास कोई भी वर्ड क्लास के बाहर हम यूज नहीं ना कर सकते सर?
नहीं नहीं कर सकते,
क्योंकि बाय
नहीं उसको
बाय डिफॉल्ट वो प्राइवेट हो जाएगा।
हाँ नहीं, लेट्स से यू डिफाइन, यहाँ पर मैंने मान लो पब्लिक नहीं किया था, जैसे प्राइवेट किया है,
हाँ।
मान लो पब्लिक नहीं किया था एंड देन आई डिड डबल अंडरस्कोर रियल अंडरस्कोर आई एम। ये वेरिएबल पे
यस सर।
एक्सेस करने के लिए आई कैन यूज डॉट, मतलब जैसे कॉम्प्लेक्स, यहाँ पर सॉरी कॉम्प्लेक्स बोलो, C1 का जो ऑब्जेक्ट है C1 डॉट
यस सर।
दैट वेरिएबल नेम, वो मैं कर सकता हूँ टू एक्सेस दिस वैल्यूज, क्योंकि वो पब्लिक बन गए, ठीक है।
यस
बट
सर।
जब प्राइवेट बनते हैं देन आई कैन नॉट डू दैट, क्योंकि ये प्राइवेट बन
प्राइवेट
चुके हैं।
प्राइवेट बनता है तो फिर से अपने से पब्लिक क्लास बनाएंगे, उसके बाद हम उसको यूज कर सकते हैं। यस सर, यही बात है।
हाँ तो उसमें क्या करना है तुम्हें कि मतलब बाहर एक्सेस नहीं कर सकते, लेकिन तुम
नहीं।
अंदर अंदर ही अंदर एक्सेस कर सकते हैं। फॉर एग्जांपल प्राइवेट जो है, तुम्हारे पास दो वेरिएबल थे ऐसे, ठीक है।
यस
तो
सर।
मैंने इन्हें प्राइवेट बनाए थे, लेकिन इस डिस्टेंस के फंक्शन में मैं एक्सेस कर सकता हूँ। सो देयर इज एक्ो, सो या ओके हाँ सो हाँ या दैट्स बेटर थैंक्स। सो क्या है कि इफ आई कॉल दिस फंक्शन जो पब्लिक है, ठीक है, इसको कॉल मतलब बाहर अपने स्कोप ऑफ ऑब्जेक्ट में कॉल करने के लिए दिस दिस आई विल कंसिडर एज आउटसाइड, ठीक है। तो यहाँ पर मैं जब
यस
कॉल कर रहा हूँ डिस्टेंस, ठीक है, तो यहाँ पर आई एम कॉलिंग दैट फंक्शन विथ डॉट, दैट्स ओके। नाउ द डिस्टेंस फंक्शन मैंने कुछ वेरिएबल पास नहीं किया, ओके, लाइक देयर इज नथिंग, देयर इज नो आर्ग्यूमेंट यहाँ पर जब मैं इसे कॉल कर रहा हूँ। लेकिन यहाँ पर अंदर ही अंदर आई एम एक्सेसिंग सम वेरिएबल्स कॉल्ड अंडरस्कोर रियल, ठीक है। एक्चुअली आई शुड थोड़ा क्लियर होने के लिए मे बी आई डू द ऑपोजिट, इनको ही रियल लगा देता हूँ, ठीक है, इसको ही अंडरस्कोर कर लेते हैं, ताकि दीज आर एनीवे जस्ट डमी, मतलब टेम्पररी वेरिएबल्स हैं, तो ये यूज नहीं होते। तो दिस विल बी लाइक डिफाइन कर रहा हूँ रियल एक्चुअल वेरिएबल फ्रॉम द वेरिएबल दैट इज पास्ट। यहाँ पर जो कॉम्प्लेक्स C1 है, इट टेक्स 1.0 एंड 2.0, ओके। 1.0 जो वैल्यू है, दैट इज व्हाट दिस वैल्यू इज, डबल रियल अंडरस्कोर रियल, ठीक है।
अंडरस्कोर।
हाँ अंडरस्कोर रियल 1.0 है, 2.0 है अंडरस्कोर इमेजिनरी। एक्स्ट्रा पोर्शन क्या होता है जब ये कॉम्प्लेक्स कॉम्प्लेक्स स्पेस C1 और ये पूरा कॉल हुआ, एक्स्ट्रा चीज क्या होता है कि जब ये कंस्ट्रक्टर कॉल होता है, इट टेक्स बाय डेफिनेशन इट विल टेक टू वेरिएबल्स, ठीक है। देन व्हाट इट डज इज रियल को सेट करता है जो अंडरस्कोर इसने पाया, एंड एंड इमेजिनरी को सेट करता है जो अंडरस्कोर इमेजिनरी इसने पाया, ठीक है। नाउ इमेजिनरी जो है वेरिएबल और जो रियल वेरिएबल है, दीज आर दीज वेरिएबल्स जो मेंबर हैं, जो एट्रीब्यूट्स हैं क्लास के, C1 ऑब्जेक्ट के। ये अंडरस्कोर रियल अंडरस्कोर इमेजिनरी फिर आफ्टर सेटिंग उनका कुछ काम नहीं, दे जस्ट गो अवे, ठीक है। और फिर एक्स्ट्रा चीज क्या होता है कि जब ये कंस्ट्रक्टर कॉल होता है, मैंने एक्स्ट्रा बॉडी डाला कि स्टैंडर्ड सी आउट
यस।
होगा विथ कॉम्प्लेक्स इनिशियलाइज्ड वैल्यू, बस दैट्स इट, इट्स एक्स्ट्रा बॉडी है बस। यहाँ पर देखो जैसे मैंने ये रन किया, कॉम्प्लेक्स इनिशियलाइज्ड हुआ क्योंकि C1 को, मतलब C1 इनिशियलाइज हो, तो ये सब सेट करने के बाद इसने ये लाइन रन की, बॉडी, मतलब ये कंस्ट्रक्टर की ही लाइन है, मतलब कंस्ट्रक्टर वाज कॉल्ड। यहाँ पर एक्स्ट्रा हम लिख सकते हैं इनिशियलाइज्ड या फिर कॉम्प्लेक्स का कंस्ट्रक्टर कॉल हुआ, ठीक है। फिर से We run this which or oh, this is a different file. हाँ तो again यहाँ पर ये variables हैं not हाँ so this is a good check actually. So underscore real जो है that is only accessible for the constructor. ठीक है, not for the member variables. So a member variables सिर्फ real है, not the underscore real. So this also needs to be changed. मैंने variables change किए, so hence we got the error. Now it is okay. अब ठीक है, now it will work because पहले तो set हो गया. So when you take these values, the real value and then the imaginary, they were set. Now when we call the distance function, these values like the real and the real, okay, you can access and then use them. Okay, I hope this is clear, Risha. Yeah. Okay, any other question? There was a token question, right? So actually what happens is token assignment. Um, there are a lot of types of tokens. So one is identifier, you have keywords, constants, strings, special symbols, operators, many things. So identifier is something like what the thing is. So like let's say uh, when we say double something, so this is like a identifier. It says it's a double. So it will have 64-bit values, bits for of representation or something. Okay. Then um, Vishal, you have a question? Otherwise, can mute because there's a echo. Anyone else have some questions, or maybe I'll just move continue this. Okay. Um. Yeah. Yeah. So there's another question. After include, is there add using namespace standard in next line? Nitish, so I'm actually not using namespace standard explicitly. So what I'm doing is I'm using the standard functions with explicit namespace. So standard, then square root, standard, then cout, and standard, and then end. You can use namespace like I discussed before. I think the first PS session. So I'll maybe mention the difference. You can use namespace using namespace standard, and then you don't need to use namespace. But it's a better practice to explicitly do use the namespace because one thing, you know what function you are accessing in what namespace. Second is it avoids conflict of functions. So maybe let's say you access some square root function, but which function is it? So maybe you have some user-defined square roots, not from the standard library, but maybe some other include files. So then it becomes easier for the compiler to know. Otherwise, it'll just throw errors. Or also you to keep track of all the variables and functions that you're using. Okay, so that is there. And yeah, like I was saying, qualifiers, right? So yeah, okay. Hope that helps. I'm sorry. Yeah. Like I was saying about tokens. So tokens, like we saw double, whatever I've defined, imaginary or real or something. So that's the identifier. It defines like what this variable is, right? So there are some rules regarding that. We'll have um, yeah, Vishal, question is first identifier I string is important. So in C++, you have different headers to include different functions. Okay. Now, thing is to print anything in C++, we generally use couts and cins, right? Like input and output. Yeah. So cout is the output and we can also have scenes and such and so on. Those are accessible only if you include that header file, because that header file includes the definition for the that function. Otherwise, you can't access them. There are a list of functions, which a list of actually header files also, which are automatically added while you compile any C++ program. In general, G++ or any other compiler will just automatically add certain headers. Just so happens that IOStream is just not one of them. Okay. So whenever we want to print anything, we have to include IOStream. So there are other headers also, like we saw last time. So hash include vector. So to access the function or the class, yeah, now I can probably say, so the vectors that we saw, that's also a class. Okay. So vector, array, standard arrays, standard vectors, standard stack, queues, anything. So all those things are classes. And to access each of them, you just have to include their corresponding header files. Okay. Uh, so the question is, if you don't use standard namespace, then will it give output or not? It will definitely throw an error. You can try it out. So if you don't use, if you don't write using namespace, okay, and then just call cout, then it won't know which cout are you calling, and it doesn't know what do you call it? What is that function? You can define your own cout or any other function, but what is that function that actually is being called? Either it has to know by, you can do it by specifically doing standard colon cout, or you can use using namespace. Using namespace standard or any other using namespace, my own namespace or whatever. When you do, it the code actually then knows that what namespace to look for, right? While searching for these functions. Again, you have to define the function in that namespace and do everything, but the compiler then knows which function it is accessing. Okay, I hope that's clear, Vishal. Yeah, like I was saying, that is yeah. Yes, there's a question. What's line 9? Yeah, okay, great. So thing is, what I was explaining here is it's actually a destructor. So this is a class. Okay. Now in a class, you have two sections, public and private. That's public and private. Sorry. In public, there is a thing called default constructor and a default destructor. Okay. Now by default, you can previously, like we saw in here, I did not need to define any constructor or destructor, but here in this example, I'm explicitly defining a constructor. Okay. So that is the line 8, where there is what I'm saying is there will be a double uh, underscore real. It will take as one input, first input. Double underscore IM will be the second input. That's what I'm doing here. So this is my complex user defined class. C1 is the object. And then I can now, previously, if you see here, I was not able to, I had to write it this way. So like using brackets. Okay. But now I can write it this way, where I'm using brackets and passing the inputs. This is essentially like calling a function, which is what is happening here. So, I mean, it's not exactly a function. I mean, in a way, it's a function, but it's more specifically the constructor of the class. Okay, where it takes, sorry, excuse me. Yeah, so the complex class takes two variables. Okay, underscore real and underscore im, where the first value is 1.0, which will be for this underscore real. Then you have 2.0, which will be for this underscore im. Now with a colon, the rest of this portion is essentially initialization of these variables. So you can so since I have real and imaginary, I initial whatever variables I got from the function, I initialize them. Okay. Similarly for im. So the bracket is the input, and what you're setting to is the outside. Now here also, in a way, it's actually a class. So double is also defined such that you can, in C++ you can write with these brackets, and then the um, variable will get set. Okay. So similarly for real and imaginary. Now this whole line with is the constructor, right? And with some body. Body just says that I have a constructor called the complex constructor class complex for the class constructor called for class complex. Okay, that takes care of the body. Okay, so this is the constructor. Now here I did not, similar to constructor, I did not define any destructor. So I have just defined a simple destructor with no body, nothing, where what you do is you have to use the same name but with a this tilde. Okay. Now, what this means is, like, what is this destructor, right? So constructor gets called when a object is created. So its constructor will get called. Now destructor gets called when the object gets destroyed. Okay. So that usually happens when the object goes out of scope. So remember we discussed scope. Scope is essentially an object lying between some parentheses, like some brackets. So essentially that is the scope of this variable, this object. Okay, C1. Now, as soon as it goes out of scope, destructor gets called. Here, normal just user defined, well, it doesn't do anything, but this destructor gets called when I don't have any user defined destructor, or I don't write it myself. A default destructor gets called. Essentially, the idea behind destructor, since a constructor creates objects, stores values, and then even the defines functions and so on. Job of a destructor is to actually clean up the class. So all the variables, so all the data, storage, anything related to functions, variables, whatever related to C1 should get cleared. That is the main idea behind destructor. Okay, I hope that's clear. Yeah, great, great. Yeah, yeah, sure. No problem. Okay. Like I was saying, maybe I'll continue with the tokens. So there's another kind of tokens where these are called keywords. So keywords are essentially um, you can think of them like a certain kind of words, yeah, which are actually reserved. You cannot use them for uh, variable names and so on. So remember we took a look at new keyword, delete keyword, and so on. Those keywords are like those are keywords. Those are kind of tokens where, yes, question like in Java file class file is created. Is it created in C++ too? Oh, so thing is in Java, as far as I understand, you have to create, I think, classes and everything. In C++, it is not mandatory because, like we saw in previous classes, you can just do when you. I mean, you have to have main function. You can write things in that. That is like um, how to put it. That is the minimum required thing you have to have. You don't have to define everything in a class and object and make objects out of it and then write your code. You don't have to, but it is not strictly enforced in C++. But it's good practice to do. In Java, as far as I understand, you have to do. So yeah, there's no class file created. More like maybe I'll explain how C++ actually works. So here I just have one single file, right? So class.cpp, class.c3-3.cpp, and so on. So and whenever I'm compiling, I'm giving the compiler, right? G++, whatever should be the final output executable, okay? And the file name. What I can do is I can also combine many CPP files. So I can, depending on how I'm writing my program, I can define, let's say, an inline function which adds to variables. Okay, include this in complex here. Call that function inline and add to, maybe add two complex numbers. Maybe I'll redefine this. And it's just a simple example. You can obviously define these functions inside this class itself. But let's say you have you want to separate things. You want to have certain functions in one file and certain functions in some other file. So those for those kind of things, what you do is you have different functions in different files. But let's say you want to use them now. Okay, there'll be one main file, and other files are just have functions. Okay, you can go a little beyond that also, but let's keep to only functions. So when you compile them, you give all the file names. Okay, so like G++, let's say hyphen out, hyphen o, hyphen o, then out, and all the file names. Okay, so what this will do is it will combine all the functions for all the files, make a single executable, and then let's say you want to run, so you do dot out or something. Now, for C++, this is a very handy feature because one, obviously keeping things separate. Okay, you can also use functions which are defined in some other files. Okay, so essentially that is what is happening here also. What we're doing is the G++. So let's say we want to use this standard cout, right? So standard cout, to know this function actually exists. Hence, we include the header file. So header file, what happens is it doesn't have the body, but just the definition that, okay, this function actually exists. So think of it, header file like this add function, but without the body. The body will be there in some other compiled code or with G++ or something. That's separate. That's the standard library. So it will be there in the library. What a simple header does is it just says that my standard cout, this function exists. Okay, and I can use them. That's all a header file does. Hence, we include them. Now, the actual body or the actual code of it gets combined with when you try to compile the code. Okay, so there are various steps to it. Sir has discussed. Maybe I'll also briefly discuss what are these steps. So first step is in a code, first the preprocessor works. So this hash include hash defines and all, they are preprocessors. So first a preprocessor will, it just, what it does is, so like if we see hash define, so a preprocessor will, wherever it sees add with this like two parameters, like for example here, it will just replace this bit, this uh, characters. Think of them like characters itself with x plus y, whatever input. So it will, since it took a and b. So essentially, after the preprocessor is done, this line will look something like this. A plus b. That's it. Now, the next step comes is, okay, I hope this hash define is clear. So preprocessor, they just blindly, whatever is defined for them, it will just, wherever it finds, let's say here there's a define, so it finds something, it will just replace. That's it. That's all it does. Now, similarly with like header files also. So the IO stream, let's say it's a huge bit of code with all the definitions and everything, standard cout, standard whatever input and output are there, standard C in everything. It will just take that code, replace that file here. That's it. Okay. So there will be a lot of definitions and everything. Imagine like whatever is inside this file will just get with hash include, it will just get replaced here. Okay. So that is the job of preprocessors. Preprocessors just replace the whole code with whatever they're defined with. So hash define will, let's say is hash define is some kind of function. So function will just replace, and the code will actually look like this. Okay. And then hash include iostream also does something similar. Okay. Now let's say I do hash include class here uh, dot cpp. Uh, yeah. So There's a slight difference how you define which you use the angular brackets or the apostrophes. So angular brackets look at the standard path. Okay. Maybe this will get confusing, but just maybe I'll talk about this later. Idea is you can include files in either way, but I want to emphasize on how this means. What this will do is I have in this folder itself, I have class.cpp. What it will do is it will copy the whole thing, whatever this whole code, and just paste it here. That's it. That's the job of a hash include. Then uh, that is what preprocessor does. The next thing is the uh, assembly. So now compiler will go try to optimize. It will go through the whole code, then try to optimize. So maybe it will see these values and then put them in registers. So like int a equals 5. So it will create some register and name it something and store 5 there, 8 some place, and it will define symbols. There are things called symbols for add and such. So those things it will define, and because it's a function, it will just inline this. So this line will be again replaced with x plus y, which will essentially also look like this. So the idea is that the like we discussed, the hash define does whatever. The end result is that even the inline also will do the same thing, but as intended. Okay. Now and then these lines also, the program will convert them to assembly instructions, right? And then the final step is to machine code, which will be just ones and zeros. Okay. That's what out is. You can create object. So the intermediate is objects. So which are usually dot o. You may have seen with a file with the dot o output. So those are objects. So if you have many files, what compiler does is it converts all of them to different object files and then combines them into one single executable, like what we want here. Okay. This is just a brief um, how a compiler actually works. Now, yeah, so there's a difference here. So, like I was saying, so with apostrophes, it will look at the current directory first and then go to see in the path. Remember, the path is like environment. Path is essentially the uh, path in your system, which where if some file or some executable or anything is stored, your program can access. So this means it will look in the default path, right? Here it means that it will look at the current path first. Then if it doesn't find, it will look in the path. Yeah. So I hope this is clear. Yeah. Any other questions? Okay. Oh yeah. I was talking about keywords, right? So keywords. Yeah. We also have seen integer, double, right? So there are also, yeah, in a way, keywords only. You have um, delete, new, and so on. So these are the tokens. Like you have under tokens also like different um, subcategories, and keywords are also like one kind of tokens. Now the question was about operator assignment. So yeah, like this plus operator. So this is something that works on these variables. So that is the assignment, the token assignment. You can have so essentially they're operators, and operations they do are by default, these are some basic operations. So you have plus, minus, division, star, then you have percentage. It's the mm, no, what is it? Sorry, the binary operations also. So you have um, double angular brackets, this one, and so on. Yeah, the not operator. Yes, and what else? Yeah, there are different many more examples. Yes. Okay. I hope that is clear. Any other questions? Yeah, today's class is done. If you guys have any questions, I can take, or we can end the class. Yeah, that's okay. Oh yeah, there was a question about protected, right? So that we did not see it now or today, but when you read about derived classes and uh, so on, so there protected is actually used. Yeah. So for today, we just saw how to create a class and define variables, the member variables, which are called attributes, define methods, the functions, the member functions of the class, and so on. So again, they can be public and private, and depending on where you're trying to access those attributes or functions, the public or private will decide. So you can either access them or do not, right? Or you can't. Protected is a little extension where protected will how do you put it? It's modified only by the derived class. We'll see what derived classes. Yeah, probably next week. Yes. Okay, great. I think can end the class. So I hope you guys enjoyed today's class. And again, feel free to ask questions if you have posted in the forum, or again, you can ask me during these TA sessions. Yeah. Okay. See you guys next week. Yeah. Happy coding. Yeah. Thank you. Thank you.